Okay, till now we have talked about the reactions of alcohols and the introduction for the alcohols. Now we move on to the next part of the specification, that is oxidation of alcohol. This is another very important reaction for alcohols. So in this video, uh, we will be understanding the oxidation of alcohols, and this is also one of the bases of differentiation between alcohols. So our focus today is oxidation of alcohols. Now, before we go into the details of this topic, we need to understand that when you say oxidation, oxidation needs, this is in presence of an oxidizing agent, in presence of an oxidizing agent. So you need an oxidizing agent for the reaction to take place. That's first step. Now, there are many oxidizing agents, but the one that is accepted is by the board is potassium dichromate in acidic medium. So H+/H+ means in acidic medium, and this is provided by dilute H2SO4. So when you are making a solution of potassium dichromate, you add some amount of dilute sulfuric acid, so that makes it acidic. Now, so this is going to behave as an oxidizing agent. We already know what is an oxidizing agent. Oxidizing agents are substances. Oxidizing agents, they oxidize other substance and itself reduced. So they will be reduced. Now, another important thing is when you are there, as I told you, there are other oxidizing agents also. Like for example, you have the KMnO4 in acidic medium. That is also used, but in your specification, they accept this. This one, they say ignore. So we will focus on the potassium dichromate. Now, when potassium dichromate, again here, the K is a spectator ion. The K is a spectator ion. That means in your exam, they may give you Na2Cr2O7. Nothing changes. The reason is it is Cr2O7, that is the active ion. It is the one that is behaving as an oxidizing agent. So now how will you represent it? You don't need to show the reaction for the oxidizing agent, but the representation of the oxidizing agent in the reaction, you have to show that you are using a oxidizing. Which one? That you don't need to. So you show the oxygen in a square bracket, and this is acceptable in your marking, in your specification here. The oxidizing agent can be represented by this. So since we are focusing on the oxidation of alcohols, so we are looking at what is happening to the alcohols. We are not focusing on what is happening to the oxidizing agent, even though we will be studying about it, because we need to know the changes in the colors and the species responsible for that. So when you're writing out a reaction, you don't need to write the whole thing, K2Cr2O7 in acidic medium. This on the arrow is enough to show to the examiner that you are using an oxidizing agent. The next thing is they talk about the observation. That is also responsible, important for your unit 3. What is happening when oxidation takes place? So for this, we need to understand that it is the Cr2O7 2 minus ion in the acidic medium. Basically, it is this thing. Even if you leave this, it is Cr2O7 that is colored, which is orange. It is an orange solution. So the K2Cr2O7 is originally an orange solution, and the color is because of the dichromate ion. The reason for that is why dichromate ion? Because chromium is a transition metal. So remember, it is the transition metals that are colored. So that is the reason why it is. Now, when it is oxidizing something, it changes into Cr+3. It changes into Cr+3 ion, which is a green solution. because it is an ion. So your observation will be if an oxidation takes place, your observation will be the color changes from orange to green. That's the first thing. Now, what is happening to the dichromate ion? The dichromate ion, if you will observe over here, it has an oxidation state of +6 and it has changed into an oxidation state of or number of +3, which means this is being reduced. So if this is being reduced, it means when you are adding this to an alcohol, alcohol will be oxidized and we will see what it is oxidized to. And this is the role of an oxidizing agent. Oxidizing agent oxidize other. So over here, the dichromate oxidizes the alcohol and itself reduced and itself it is reduced to Cr+3 ion. And now you know the changes in the color also. So this is all about your oxidizing agent. They may ask you which species is responsible for the orange color. You will say Cr2O7 minus. Which species is responsible for the green color? You will say Cr+3. That's the first thing. So we have talked about the oxidizing agent. Now let's talk about the alcohols. So we are saying alcohols are oxidized. Now the problem is we know that alcohols can be primary alcohol, they can be secondary alcohol, and they can be tertiary alcohol. Now, that is the reason why this reaction is very important. The reason is all the three of them, they behave differently. It's not the same. When you oxidize the primary alcohol, they change into aldehydes. They change into aldehydes. That means oxidized to aldehydes. And the aldehydes are further oxidized to carboxylic acids. We will discuss the name and the structure for this. Just it is a summary, and from here we will go into the details of each. The secondary alcohols, they are oxidized to ketones. And after that, the reaction stops for adhesive. And the tertiary alcohols, they resist oxidation. That means they do not undergo oxidation. That's the basic. Now we will go into the details. We will take an example of each one of them to understand. Now, before I go into explaining the details, let us understand what is an aldehyde, carboxylic acid, and ketone. The details are at A2 level, but here we should be able to name them and identify whether it is an aldehyde or a carboxylic acid. Now, for aldehyde, the functional group is C double bond OH. You can write it as this way, but you cannot write it this way because this becomes an alcohol. So here we write it this way because we know H has one valency. So H is separately attached to the carbon and oxygen is separately attached. This will extend from here. That means more carbon will be on the left side. The importance of this functional group is that it is always terminal. That means it will never be in the middle. Like for example, if you have this thing as a hydrocarbon chain or organic compound, the aldehyde group will be either at this end or at this end. It cannot come in between. Why? As you can see, carbon has 4 valencies. It is already using the 3 valencies. Only 1 valency is left. So it can extend from only on one side. The next thing is, how do you name them? How do you name them? Now, naming is based on the name of an alkane. Like you have an alkane. Alkane means how many carbon atoms are there. So what you do is you remove this E. You remove this E. So minus E. So you get alkane. And for an aldehyde, because it has this functional group, you add al to it. It becomes alkanal. You don't need to write any positions. You don't need to write any positions. The reason is it is always in the first position. If it is here, you will start counting from here. If it is here, you start counting from here. Because the rule is that the carbon of the functional group should get the minimum possible number. This is all about your aldehyde. Then coming to ketones. Ketones, their functional group is this. Or you can write it this way. This is a displayed formula, and the other one is the condensed. Now here you can say, you can see over here that it is open from both the sides. That means this is never terminal. This can never be terminal. And I'm giving you very short just to understand our oxidation process. There is more, the whole topic is there, aldehydes and ketone at an A2 level. So I'm not going into that. And how do you name them? How do you name them? Naming is again based on the name of an alkane. You remove the E, you remove the E, and add on to it, plus on to it. So it becomes alkane known. And since it can be anywhere in the parent chain, depending on the, you can write down the position also. You can write down the position also over here. So this was all about ketones, naming and the identification of the functional group. Then moving to carboxylic acid, you have done this at an Ig level. Carboxylic acid. Carboxylic acids are represented at RCOOH. Aldehydes are represented at RCHO. That means R represents the alkyl group. How many carbon atoms are there? And this is a functional group. The ketones are represented at R, C double bond O, and R dash. That means both sides there is alkyl group. R and R dash we have written. That means on this side, they may be same or different. And same way for carboxylic acid. This is a functional group. You can write the displayed formula this way, or the condensed formula this way. Now their name is also, another important thing is they are also always terminal. So their position will always be 1. As you can see, the 3 valencies are already used up over here. So the chain can extend only from this side. So either on the left end of the chain or the right end of the chain, this will exist. It will not be present anywhere in the middle. The naming is also based on the name of the alkane. Alkane means how many carbon atoms are there in the parent chain. So you remove the E, and add oic acid to this. Add oic acid to this. So this will become alkanoic acid. It will become alkanoic acid. You don't need to write any positions over here. The reason is it is always terminal. Let's take an example to understand the naming. Like for example, if I'm giving you CH3, CH2, CHO, I'm giving you CH3, C double bond O, CH3, and then CH3, CH2, COOH. So all the 3 have the same number of carbon atoms, but the functional group is different. Here it is CHO, here it is C double bond O, and here it is COOH. Now, if I want to write down the name, there are 3 carbon atoms over here. In the first case, in the first case, there are 3 carbon atoms. So for 3 carbon atom, the name has to be propane. For 3 carbon atom, the name has to be propane. So what I'm doing is I'm removing the E and adding ul to it. Finish. Propanol. If there is a double bond, which you will not come across, then it will affect this part. If there is double bond over here or somewhere else, but this you will not come across. So the main thing is you have added the ul. You don't need to write down the position because it is always first position. Now here also there are 3 carbon atoms, so it should be propane. But what we are doing is we are not writing the E, removing the E, and in its place I'm writing the O. Now you will see I have left a space between them. The reason is if I want, I can write its position. Like here, this is 1, 2, 3. So I may, if I need, I may write it. Otherwise, it is not important because there is no other possibility. No other possibility means this cannot come to the first position or cannot go to the third position because it cannot be terminal. So even if you write it as propanone, it is still correct. The third case, the third example, again, there are 3 carbon atoms. So propane, remove the E and write the oic acid. So you can see the difference is in the function group. The difference is in the function group. The number of carbon is the same. So the starting part of the name is the same. So I hope we have understood these 3 new organic compounds. Now let's start with the oxidation, how to show this. If you take a primary alcohol, so let's focus on the oxidation of you already know how to identify primary, secondary, and tertiary alcohol. So let's say I'm taking a primary alcohol, CH3, CH2, and let's take CH2OH. It could be written this way. It could have been written like C3H7OH. I prefer this way because it gives me it shows me where the reaction is taking place. The oxidation will take place. That means you will have to use the oxidizing agent. Now the important thing. Now you are doing the oxidation. You know alcohols will be oxidized to carboxylic acid. So what you do is, or what we can do is, the first thing is write down the function group, because I know aldehyde will be formed 100%. When alcohol is oxidized, primary alcohol, this is a primary alcohol, aldehyde will be formed. So I have written the functional group first. Now I started with 3 carbon atoms. I have already used one of the carbon atoms, so I'm using the other 2. I'm using the other 2. And then I complete its valency. And then I come. So this way, it makes it easier for me to understand which aldehyde will be formed. It is CH3, CH2, and CHO. Then this aldehyde will be further oxidized to carboxylic acid. So carboxylic acid means it should have a C double bond OOH. So I'm already using one of the carbon atom. I am left with 2 more carbon atoms. So it will be CH2 and CH3. If it comes to naming, there are 3 carbon atoms. So this will be propane, and it is an alcohol. So propanol. This is 3 carbon atoms. So it is propane, and it is an aldehyde group. So propanol. And there are 3 carbon atoms. So it is propane, but there is a carboxylic acid, so it is propanoic acid. That's a simple thing. Important thing is the number of carbon atoms. Number of carbon atoms remain same. Observation, because the oxidation is taking place, your observation will be orange solution turns to green solution. The species responsible, orange solution is because of Cr2O7 2 minus. The green is due to Cr plus 3. So you need to first write down the functional group, start with the functional group, and then take the rest of the number of carbon atoms, any number of carbon. But take care that the total number of carbon atoms, they do not change. The number of carbon atoms are not changing. Now, the next problem with this is the conditions. Means when aldehyde will be formed, when ketones, carboxylic acids will be formed. So when the primary alcohol is oxidized under the condition, now the examiner will use 2 things. Or you can, if they ask you the condition, you can say under simple distillation, or you can say the product is distilled off. Product is distilled off, or sometimes the word used is removed. We will try to understand what it means. if the examiner is saying the primary alcohol is oxidized under simple distillation, or they say the product is distilled off, then and then they ask you what is the end product, you would say aldehyde. You will not say carboxylic acid. But if the examiner says the primary alcohol is oxidized under reflux heating, in that case, the product would be, the product is your carboxylic acid. So you need to be careful what the examiner is saying in terms of condition. Whether it is reflux heating, if it is reflux heating, then it is carboxylic acid. And if it is simple distillation or product is distilled off, then your answer will be aldehyde. Now, how this happens, why this happens, let's understand this. Now, when they say primary alcohol is oxidized under simple distillation, or distilled off means removed, then you end up with an aldehyde. Let's try to understand this. How do we carry out? So this is carried out like this. This is a simple distillation apparatus. This is a simple distillation apparatus. Here what you are doing is you are taking the potassium dichromate in acidic medium, which is originally orange in color. It is green over here because it is showing the change in the color. It will turn to green. So you have the potassium dichromate over here. You will add the alcohol over here slowly. You will add the alcohols over here slowly so that you can control it. Now, as the alcohol drops over here, you may have to warm it. You may have to warm it for the reaction to speed up. Now, as the alcohol mixes with the potassium dichromate, the reaction starts. The aldehyde will be formed. Now, the aldehydes have lower boiling points than alcohols, and the reason for this is alcohols have a hydrogen bond between the molecules, while aldehydes cannot have hydrogen bonds. So their intermolecular forces are weaker in aldehydes. So they have a lower boiling point. More details again for aldehyde at a A2 level. So aldehydes, what will happen is the aldehyde vapors will start vaporizing off. So since they have a lower boiling point, what will happen is the aldehyde will vaporize and condense. So the aldehyde vapors will go over there. It will enter the condenser, which is a Liebig condenser. This is your condenser. It goes through over here. We know that water is always in from the lower one. We have talked about this before. And at the back, there must be an outlet, which is water out to keep the inner tube cool. So the vapors of the aldehyde will go over here. It will collect over here. So the aldehyde will the aldehyde vapors will condense and are collected. Now, when they are collected over here, there is no oxidizing agent. There is no oxidizing agent over here. The oxidizing agent was in this pear-shaped flask. So since there is no oxidizing agent, it means no further reaction or oxidation. Instead of saying reaction, no further oxidation. So the reaction stops at this level and you end up with an aldehyde. So the meaning of simple distillation is like this. The vapors will go and condense. Distilled or removed means distilled off, or remove means you are removing. So you can see you are separating it from the oxidizing agent. So you end up you end up with a aldehyde. So this is the meaning of primary alcohols oxidized under simple distillation or distilled off. And this ends up with an aldehyde. The second thing is the secondary if you are doing, yes, if you are doing the primary alcohols oxidation to an aldehyde, and then we need further oxidation of aldehydes to the carboxylic acid, it means we don't need to separate the aldehyde. We don't want the aldehyde to go over here. We want the aldehyde to stay. We want the aldehyde to stay in the flask. Why? Because we need it further oxidation. So for this, the condition is reflux heating. The condition is reflux heating. Reflux heating means we already know you need a reflux condenser. You need a reflux condenser. So what does a reflux condenser look like? We have done this in haloalkanes also. We have done this in the haloalkanes also topic. So this is a reflux condenser. Here. So here what is happening is you have your potassium dichromate, your oxidizing agent. Originally it is orange in color. As the reaction takes place, it will turn to green solution. And we know which species is responsible for the green and which is species responsible for the orange color. And then you have your alcohol over here. Now, as the reaction proceeds, initially the alcohol will be oxidized to an aldehyde. Now we know aldehyde vapors or aldehyde has a lower boiling point. So they will try to escape out. They will try to go over here. This is your water in. Always from the lower end, somewhere at the back, the water out is over here. So as these aldehyde vapors try to escape out, there is a cold water around it. So they will condense back and they will fall back. When they fall back, they again mix with the K2Cr2O7 and then they are further oxidized to carboxylic acid. So you are not allowing it to escape out. Just a quick refresher that this should be open. And we know why. So that pressure is not created. Otherwise, it may explode. So if any vapors, maybe 1 to 2% of the vapors are not condensed, let them go out because it may create pressure and it may explode. So this has been asked before in the exam that the reflux condenser should be open at the top or not. So this is your reflux condenser. So this was all about your primary alcohols getting oxidized under different conditions to aldehydes and ketones. Secondary alcohol, it is easier. Secondary alcohols, they are oxidized to ketones. Here also you just say reflux heating. And what will happen? Let us say you have a CH3, CH2 and CH2OH. Now, can we use this example? No, we cannot use this example because I need a secondary alcohol. So this example is wrong. This is a primary alcohol. Primary alcohols will not be oxidized to ketone. So I have to take a secondary alcohol. To take a secondary alcohol, I have to put at the OH over here. So this becomes your secondary alcohol. Now, when I oxidize it, you just need to remember where the carbon on which the COH, the OH group is attached. The carbon where the OH group is attached, convert this into a ketone function group. Convert this into a ketone function group. And then on both the side, whatever is there, copy and paste. So you copy and paste the rest of the thing. So the only change that is taking place is here. The carbon that carries the OH group, that changes into this. And this becomes a ketone. This was your propane 2-ol, and this will be propanone, or if you want to write, you can say propane 2-ol. Finish. This is your ketone. Ketones are not further oxidized. The tertiary alcohols, they resist oxidation. The question is why? So to understand this, we need to look at the structure and what is happening in the oxidation process. What is happening in the oxidation process, we need to understand. So for that, I need to draw the displayed formula for each one of them. Let's talk about a tertiary alcohol. Let us say your tertiary alcohol could be like this, like here. So its name will be 2-methyl propane 2-all. The reason is this is your function parent chain. The substituent, the methyl group is at the second position. 1, 2, 3. So 2-methyl, and there are 3 carbon atoms in the parent chain. Prop, all are single bond. So N, and the OH is at the second position. So this is your tertiary alcohol. So we need to understand why the oxidation tertiary alcohols do not undergo oxidation. To understand this, we will first look at what is happening in the primary, secondary, and then we can easily understand what is happening in the tertiary. So let's try to look at the primary alcohol first. Let's say I have CH3, C, H, H, and OH. I'm taking this as a ethanol. Now, when it is oxidized, I'm focusing on the carbon that carries the OH. So that's why I'm writing this as a displayed formula. When it gets oxidized, what happens is it will form an aldehyde. Aldehyde means C double bond O and H. Now, if you observe over here, what is happening is the hydrogen that is attached. Okay, let me write exactly the way this is written here. This was double bond O and H. That doesn't matter, but it's just to make it easier to understand. So what is happening is the hydrogen which is attached to the oxygen, that is gone, removed. And one of the hydrogen that is directly attached to the carbon, that is also removed. So when it changes from here to here, what is happening is there is a removal of 2 H atoms. And then in it, they will form water molecule, which I was not writing over here because we are focusing on the organic product. We are focusing on the organic product. What is the organic product here? So I was just saying aldehyde and ketone. Somewhere I had written the reaction. Here, I did not write. If you want, you can write it down. But the main thing is our the aldehyde. So you end up. So here, the hydrogen attached to the oxygen and the hydrogen attached to the carbon carrying the OH, they are removed. And removal of hydrogen is oxidation. That is one thing. The second thing is this aldehyde is then further oxidized to carboxylic acid. So here what happens is now you have the double bond is already there. You have the O and the H. So what is happening here? Addition of oxygen atom. So again, addition of oxygen atom is oxidation. So both the process, the aldehyde converting the alcohol converting into an aldehyde is oxidation because of the removal of the H atoms, and the aldehyde oxidizing into carboxylic acid is also an oxidation, but the reason is there is an addition of oxygen atom, and here it is a removal of. So again, focus on which hydrogen atoms have been removed. Which hydrogen atoms have been removed. Now, when you look at the tertiary or secondary alcohol, let's say I have here, this is your secondary alcohol and its name is propane 2-all. Now, when this will be oxidized, as I told you, you need to focus on the carbon that carries the OH group. So first of all, what we do is we convert this into a ketone and then write down the rest of the groups and write down rest of the group. Now, if you will observe over here, okay, I should, yes. If you observe over here, what is happening? The hydrogen that is attached to the oxygen and the hydrogen that is attached to the carbon that carries the oxygen, it is removed. So removal of two H atoms, and that is oxidation. But now, if you look at the tertiary alcohol, so whether it is primary or secondary, in both the cases, the first step is the hydrogen attached to the oxygen and the hydrogen directly attached to the carbon carrying the, that means I'm talking about this. This is called as, it is also called as a alpha hydrogen. The reason is this carbon is called as a alpha carbon. You can write down this in your marking scheme, but in Edexcel it is not. According to the marking scheme, they accept it, but in Edexcel they don't talk about it. So we will see how to explain it. So in both the cases, it is the same hydrogen. The positions of the hydrogen is the same that is being removed. Now, if you look at the tertiary alcohol, I need the two hydrogen atoms. The first hydrogen atom is here. There is the hydrogen atom directly attached to the carbon carrying the, carrying the OH group is absent, not present, not available, whatever you want to write down. So the other hydrogen is not there. Therefore, it resists oxidation. Therefore, the oxidation does not take place. This is according to Edexcel. In actual practice, under drastic condition, that means you will have to heat it more than it may undergo. But in Edexcel, we stop at this step. So if someone asks you why the tertiary alcohols do not oxidize or they resist oxidation, this is the reason. Instead of saying all this thing, the hydrogen atom directly attached to the carbon, you can simply say the alpha hydrogen. You can simply say the alpha hydrogen is absent. You can even use the word the alpha H is absent. That also is accepted by the marking scheme. The next thing, for your unit 3, they may ask you, like you are provided with an alcohol, and it undergoes oxidation in presence of K2Cr2O7 in acidic medium. Now there are two possibilities. Either there is a change in color from orange to green, or from no change in color. So what is your inference or conclusion? Means if you are oxidizing an alcohol and it changes its color from orange to green, what is your inference? What conclusion you can draw? Or if there is no change in color, so if there is a change in the color, it means it is either the primary or secondary alcohol because they undergo oxidation. And if there is no change in color, that would mean it is a tertiary alcohol. That's the first difference between them. So based on the oxidation of alcohol, you can identify whether it is primary, secondary, or tertiary. So let us say we were able to differentiate out that it is tertiary, but I still need to figure out whether it is primary or secondary. So when you oxidize alcohol, I don't know whether this alcohol right now, because there was a change in color from orange to green. So I know it is either the primary or the secondary, but I don't know what it is. So what you will do is this oxidation product, that means when it is oxidized, it will form something. What it is, we don't know. What it is, we don't know. We call it as an oxidation product. So we analyze this. Analysis of this is done to prove whether it is primary or secondary. We will test the oxidation product to decide whether it is aldehyde, the starting substance was, or the oxidation product is aldehyde or ketone or carboxylic acid, and the starting material is primary or secondary alcohol based on the oxidation product analysis. So once you do the oxidation, whatever product is left, that is means the product of the reaction, which we are calling it as oxidation product, you will test it. Now, we have talked about the OH before. The carboxylic acid. How will you test for the carboxylic acid? Now, first of all, the test for carboxylic acid and alcohol is the same. We have done this before. You go for the test for the OH group. Test for the OH group. And test for the OH group is you react it with a test with PCl5. We have done this in the previous topic. With the PCl5, you get steamy fumes of HCl gas that indicates the OH group is present. The OH group is present. So right now we are not focusing on the OH, we are focusing on the carb, or we can say how will you differentiate between these two. You can even talk about this thing, how to differentiate between the carboxylic acid and the alcohol. So once you know the OH group is present, it means it can be an alcohol, it can be a carboxylic acid. It can be alcohol, can also be written as ROH. So it can be an alcohol or a car. How will you differentiate? Add sodium carbonate or sodium hydrogen carbonate. So what will happen is, if you observe bubbles, it means it is carboxylic acid. And if there are no bubbles, so the reagent which you think is an alcohol, that the unknown substance you are given, your X substance you are given in the test tube, you want to know whether it is an alcohol or a carboxylic acid, because it gave you the test for the OH group. It gave you the steamy fume. So you take again the X in the test tube and add sodium carbonate or sodium hydrogen carbonate in it. If you observe bubbles, it means it is a carboxylic acid. And if there are no bubbles, it means it is an alcohol. The reason for this is our concept of that the metal carbonates, they react with an acid to give you salt, water, and carbon dioxide. So it is this carbon dioxide that shows you as a bubbles. Alcohols are not acidic. So to know whether an aldehyde, whether a carboxylic acid is present or not, you simply have to add to the oxidation product some amount of sodium carbonate. If there are bubbles, it is an indication it is carboxylic acid. The next thing is, how will you differentiate between aldehyde and ketone? Now, there are many reagents to differentiate. We will not go into the reactions. What are the reactions? We will only focus on the observation. Reaction and observation, the details are at A2 level, because this is a separate topic. So to the oxidation product, what you do is you add Tollens reagent and warm. Now, what is tolerance reagent? If you want to know, it is simply ammonical silver nitrate solution. How to make it? Again, that is for A2 level. You will observe over here silver deposits in the test tube. You will observe silver deposits. This is also called as a silver mirror test. We also, that is why we also call it as a silver mirror test. So in the test tube, there will be deposits of silver. So it will be shiny. Over here, there is no change. That means there is no observation, no change in the. So this is one of the test. So if you have an oxidation product, you are not sure of whether it is aldehyde or ketone, you add ammonical silver nitrate and then warm it. If you get the silver deposits, it means it is an aldehyde. If you don't get the silver deposits, it means it is a ketone. Now, then there are another reagents that are Fehling solution and Benedict solution. Now, in both of them, you have the copper ions. The copper ion is complex with citrate and tartrate ion, but as I said, we don't need them right now. This is a blue solution because of the copper. The Fehling and the Benedict are blue solution. So we don't need to know what it is complex to, because even at A2 level, that is just for understanding. Otherwise, why they are added and so on, we don't care about that. Now, if it is an aldehyde, you will get a red precipitate. And over here, there is no change, no red precipitate. Red precipitate is Cu2O. Cu2O is copper 1 oxide. Copper 2 oxide is black in color. This is a red precipitate. So if you get in the oxidation product either a silver deposit by adding a tolerance reagent, or you are if you add the Fehling's and the Benedict solution and you get a red precipitate, it is an indication that the oxidation product is an aldehyde. And if the oxidation product is an aldehyde, it means your starting substance was primary alcohol. Your starting substance was primary alcohol. And if there is no change in the color with either the tolerance reagent or the Benedict solution, then it means your starting alcohol was secondary. And if there is no change in the color with the potassium dichromate, that means it is a tertiary alcohol. So we have done this whole thing today. You have done primary alcohols to produce aldehydes, which give a positive result with Benedict Fehling solution if the product is distilled off, because the distilled off will then provide the aldehyde. And the primary alcohols to produce carboxylic acid, which gives a positive result with sodium carbonate and hydrogen carbonate if the reagents are heated under reflux. So that is a condition to produce carboxylic acid. And secondary alcohols to produce the ketone. Now you will see they did not talk about the tertiary alcohol, but they may ask you why tertiary alcohols are not oxidized. So this part we have done. So basically that should complete your alcohols. This completes your alcohol.